bring you back to that point. Yesterday, all of our focus was on f prime of x equaling 0 because everything we looked at yesterday were polynomial functions. Today, this is not a polynomial function. So now the critical points are going to occur when f prime of x equals 0 and when f prime of x does not exist. So the derivative will equal 0 on a fraction when the numerator equals 0. So that's going to occur at 0. The derivative will not exist when the denominator equals 0. But what do we know about when this is going to equal 0? What value can you plug into x that's going to make that 0? 4 minus 2 squared, or 4 minus 4. How do you get 4? Well, it's x squared, so you need 2. So we get x equals plus or minus 2. But what do we know about plus or minus 2?
It's not included.
It's not in my domain. If it's the critical points we get on the derivative are not in the domain of the original, they can't be critical points. If the critical points of the derivative are not in the domain of the original, they cannot be critical points. So that is why we have to be cautiously aware of the domain of the original. That's why I had us look at it. So therefore, x equals 0 is the only critical point. So what is f of 0? How do I know if that critical point is a min or a max?
Depending on.
You have to plug in the other bounds.
So what you could do to figure out if it's a min or a max is actually look at what's happening around 0 on the derivative.
You just look at like the behavior of the regular graph too.
Yeah, it'll just be harder than if you look. I mean, if you know what this looks like, then that's fine. But like, I wouldn't really know too much about what a square root of a square, like a quadratic, looks like. So if you look at the derivative, right? So our derivative is x all over 4 minus x squared to the 3/2. So what's a little bit to the left of 0? Yeah, what's a little bit to the right of 0? Yeah, so that doesn't help me for the denominator, right? Because no matter what, they're going to be the same sign. So then where does the comparison happen? In the numerator. So to the left of 0, you're going to get a negative, because it'll be -1. To the right of 0, you get a positive, because it'll be +1. So we're talking about the derivative now, right? So if the derivative is negative, what's the original function doing? The derivative is negative, the original function is
Decrease.
there it is.
Yeah. Oh.
If the derivative is positive, the original is. So yesterday I made you guys draw all over these graphs and tell me max, min, increase, decrease, and we had talked about like what happens. So if a graph goes from decreasing to increasing, it makes it a. Thank you. And because of the extreme value theorem, this is an absolute min. It's an absolute min because we have a closed interval domain and only one critical point. Yes?
Was it a closed interval domain?
Won't it be open because 2's not included?
Yeah.
I still know it's an absolute because like I know the graph. So yes, like EBT is not necessarily going to apply.
Oh, I know why. Because it's below it, though. Right?
Yeah, but I thought whenever there's...
If there's only one critical point, I'm thinking how to justify why it's an absolute.
No, because there's no locals. It's not possible for it to be local.
It's just that it's it's a singular critical point on the entire domain of the whole function. So like, you can't say by EBT. It's kind of by like the function's domain itself.
Is it because it's not odd either? Because like if it was odd, it would be. You can't say it's an absolute since it's even. You know it has to be either like a top or a bottom. It's like it's going in the same direction.
Yeah, this isn't one they're going to put on there. If they ask you for an absolute, it'll be a closed interval. Or if they ask you to justify EBT.
Okay.
I think about how I can determine for you a logical reason beyond just using logic. Like if there's a mathematical reason.
Like, is it safe to assume that there's only one critical point?
And because this is the entire domain of the function. So yesterday, when we were looking at the quadratic, we said it had one absolute min on the whole domain because we knew that the quadratic only goes in one direction. Do you know what I mean? On its entire domain of all reals, you could only have one critical point of a quadratic. Because a quadratic looks like that.
Yeah.
So it can only have one in either direction based on the powers of the domain. So here, this is kind of like the square root of something squared, so its power is x. So again, it's in that position where like, based on its degree, it can only have one. And this is its domain. So it's on its entire domain, there's only one critical point.
Okay.
So the other ones are shrinking your domains. And if you shrink a domain, then you're guaranteed an absolute maximum. That's what EBT says. EBT says, I can shrink a domain and guarantee you one of each. Because it is a beginning and an end, so you have to have one of each. This is saying, okay, this is its whole domain, and it only has one CP, therefore that CP is an absolute.
Okay.
Yes. Okay. I think we were misinterpreting the wording of EBT, and then I was confusing you, and then I was confused because I was like, wait. But yes, like, because EBT is restricted domain of a function.
Okay. So if it's not restricted.
And EBT guarantees.
Okay.
It's not saying that there aren't other cases, it's just saying it guarantees on its specific case. Okay, so find the extreme values of the given function. So now we have a piecewise. In order to determine what our piecewise looks like on its domain, we need to know 1, is it continuous? And we need to know 2, does it have a derivative? So you need to find f of 1 for both the top and bottom. So we see that this is not continuous. So basically what not continuous means is that EBT would not apply. We're not guaranteed absolute values. It also tells me that 1 is going to be a point of concern for where the derivative does not exist. So again, today's aspect is, okay, where's the derivative 0 and where does the derivative not exist? So what is the derivative of this? Well, its derivative is negative 4x and positive 1. because these do not match up, the derivative does not exist at 1. Therefore, when I rewrite my bounds, they do not include 1 anymore. So when you talk about f prime of x does not exist, f prime of x does not exist at 1. It makes 1 a critical point of the original. When is f prime of x going to equal 0? Well, the bottom function is never going to equal 0 because it's horizontal. When is it going to equal 0 here? 0, 0. So 0 and 1 are my critical points. These two values are the only possible locations on f of x at which we can have an absolute max, an absolute min, or a local max and a local min. They're the only possible locations. Yes?
So, I don't know, maybe I missed this yesterday. Why did we set it equal to 0?
Because at the absolute min and max is the slope is like the bottoming out part, so the derivative is the slope 0.
Think back to physics, right? So ball goes up in the air and comes back down. So this is its position function.
Yeah.
So when does the ball change directions on its position function? At the top. So this is where the velocity is increasing and then velocity is decreasing.
Okay.
So in order for velocity to change from increasing to decreasing, it has to go through the 0.
Yeah.
So the max or min of an original position are a 0 in velocity.
So you're trying to find a change in direction.
So exactly.
Okay.
What we're doing is we're taking the derivatives so that we can find the max and the mins of the originals, because we know the derivatives are going to be 0 at the max and mins, because the function, again, it all goes back to that chart way back when, right? So you have f prime. If a function goes from increasing to decreasing, the only way for it to go from increase to decrease is to have an extrema in the middle.
Okay.
On a derivative, the only way for us to see that is it goes from positive to negative. Well, the only way for a graph to go from positive to negative is to go through 0.
Okay.
So essentially what we're saying is f has an extrema when the derivative is 0.
That makes more sense. Thank you.
You're welcome. Yes?
So when you mean increasing or decreasing, you mean on the y terms? Like a quadratic?
Yes.
So like increasing to decreasing? So that, okay. So I'm thinking when you mean that on the domain, I'm getting confused. So.
Sorry.
No.
I mean, I guess technically the domain is increasing too, because you're going from right to left. Or, sorry, from left to right. Okay, CPs are 1 and 0. So what you have to do is go back to the original and find f of 1 and f of 0. And you have to be careful to plug them in correctly. So f of 1 is -7 because 1 is included on the top function. F of 0, well, 0 is included on the bottom function. So f of 0 is -5. So, again, you have to talk about, is it increasing or decreasing around those points on the derivative? So the derivative of f prime of x, and both of these are going to be included here. This is a negative linear function. What's a negative linear function doing?
Decreasing.
And it's decreasing
Constants.
always, right? Like it's always decreasing. So if the derivative is always decreasing, then the original function is like concave down. So these can't be absolutes because this is always decreasing. So these are local and a local.
So yesterday, how we did stuff like this, we had like 5 values we had to plug in, but we didn't say that every single one was either a local, min, or max, right? Or did we only say?
We were looking for the absolutes yesterday.
But all the other ones would have been local.
Mhm.
So every single one has a label. She's figuring out if it's absolute or local.
Yes. All critical points for now are those. We're going to talk about the first derivative test, and that will help eliminate ones that are.
Wait, what did you say?
We're going to go first derivative test, and that's how we're going to be able to eliminate points that are not absolutes. Yes.
So in that last one, you had 2 local minimums, but how would you know that that's not a possibility that other one's a max?
Because that's why I looked at the derivative. This is always decreasing.
Oh, okay.
So if the derivative is negative always on that domain, because all of those, then it's always decreasing.
All right. We'll see.
Okay, so your derivative is 3x squared. This is an open interval, and it's a cubic. So that means we cannot have an absolute, right? It can only be local. So the locals occur when 3x squared equals 0, which are only at 0. But again, to determine if it's a maximum or a minimum, you need to determine if it's increasing or decreasing around the 0. So if you plug in a negative number, it's like negative 1 squared is,
This would just be
so you get,
positive.
you plug in a positive 1, okay.
That's the minimum.
So if the function is increasing,
It's like the last one wrong.
Absolute.
It's min. It's local.
Absolute.
Max.
No.
An absolute
graph
min.
y equals x cubed on your.
It looks like this. Oh, what? You mean the cube?
No, it's just this. Like,
We're trying to determine, I told you, this was, I think that one I gave you. You're trying to determine
Wait.
if 0 is a maximum or a minimum.
You plug it back into the
It's
original.
neither.
Or
yeah,
I want you to, for this, you were plugging into the derivative. That's why it's all in black.
No, it's a
So
minimum.
does a cube,
Oh, no,
a
that's not.
function, have a max or a min?
dumb either.
It does, but not that. Not at 0.
Where would it be then?
I feel like the look goes up.
It
and
doesn't
then
go
down
like this. And at 0, it's at the origin. But they would just be local, so they wouldn't be an actually.
Use your calculator. Do second trace and try to find maximum. You do maximum, you do minimum. Yes. You can find it up. And do it near 0, because we're saying 0 is something.
Oh, it's not. It's nothing. There is no.
Is there a hole?
It's
what graph am I graphing?
X cubed.
Ah.
It's not the one that goes up and comes back down. It's just this. It's the graph looks like this.
We did it at 0, right?
So it's
Around
just,
it, so you go a little bit to
right?
the left, a little bit to
Doesn't
the
the
right.
graph
It's
look
just
like
the
this?
part where the slope is 0.
No, it plateaus kind of, right?
Mhm.
So like it goes straight and back.
So, it's plot, what did your calculator tell you?
I think that's important.
Or is it?
I said it first.
And that's the case that was happening yesterday. Here, when you have a repeated root, it plateaus, therefore there is none. And that's why this is positive, positive. Therefore there is none. All right, I want you to do some problems in your book. Do the ones that followed after what we did yesterday. So you're back on page 193. 3. Thank you. I wanted to say 5, but I knew it was wrong. So we ended, remember I skipped, I stopped at 22?
Yeah.
So pick up at 23, and I don't know when that section ends, so I'll just
30.
make up a number. It ends at 30.
Mm-hmm.
And what follows after it?
31 to 34 is group activity. Find the extreme value.
Yeah, just do 23 to 30.
23
And then 40, 39 and 41. Because those are key slides, and we did
39
those.
and 41.
Yeah. So 23 to 30, 39, 41.
Can you just send me a picture of the pages, please? Or that one, whatever.
For calculus.
Where'd you go with that?
You just say that. I haven't given you
There you go.